James Webb just did something no telescope has ever managed to do before. It took a real, direct photograph of a planet orbiting a star that isn't our sun. But that's not even the strange part of tonight's story, because once scientists looked closer at everything Webb found afterward, they uncovered a planet that shouldn't exist according to our own science. A planet that might be hiding an entire alien, ocean underneath its clouds, and one world sitting so close to us that we still can't see what's actually happening on its surface. Tonight, we're counting down everything Webb just revealed, starting from the most surprising and working our way toward the discovery that has scientists genuinely questioning what we thought we knew. Trust me, number 3 on this list is the one nobody saw coming. Subscribe right now before we start, because this list only gets stranger from here. Let's start at number 5, with the discovery that made all of this possible in the first place. For years, taking a direct image of a planet outside our solar system was considered nearly impossible. The problem comes down to basic physics. A star outshines any planet, orbiting it by billions of times. Trying to photograph that planet is like trying to spot a single candle flame standing right next to a lighthouse, except you're attempting it from an entirely different city. Every telescope before Webb ran directly into this exact wall. The starlight simply overwhelmed everything else in the frame. James Webb solved it, using an enormous primary mirror combined with instruments specifically engineered to block out overwhelming starlight. Webb finally achieved something scientists had only ever dreamed about on paper. And here's the part that genuinely surprised even the engineers who built it. Webb didn't need years of trial and error to get there. It succeeded almost immediately during one of its very first serious attempts. That single fact alone tells you everything you need to know about how precisely this telescope was designed before it ever left the ground. Number 4 on tonight's list is the planet that broke the rulebook entirely. It's called HIP 65426b, and it's nearly 7 times heavier than Jupiter. On its own, that's already an enormous amount of mass for a single planet to carry. But the real mystery isn't its size, it's exactly where this planet is sitting. According to everything we currently understand about how planets form, an object this massive needs to form close to its star, inside a thick disk of swirling gas and dust dense enough to provide the raw material for a planet that large. HIP 65426b isn't anywhere near that region. It's drifting alone, far out in the darkness, in a location where our models say there simply wasn't enough material available to build something this big. So scientists are asking an uncomfortable question. Did this planet actually form somewhere else entirely and end up here later? Some researchers now believe it may have been violently ejected from a completely different star system during some ancient chaotic collision, only to be captured afterward by the gravity of its current host star. Others suggest it might have formed, alone in true interstellar space, wandering freely as what's known as a rogue planet, until it was eventually pulled into orbit. Researchers have started calling planets like this orphan giants, worlds that lost their original star system entirely, and were later adopted by a completely different one. If that theory holds up, our galaxy could be quietly filled with wandering giant planets drifting between star systems, occasionally settling into orbits that make no logical sense according to our current understanding of planet formation. Number 3 is the discovery that shocked scientists more than anything else Webb has found so far, and it's the one we promised you at the start of this video. This planet is called K2-18b, and it wasn't originally expected to become anything special. It was simply treated as another distant super-Earth, too large and too far away to study properly with older instruments. But once Webb pointed its mirror directly at it, everything changed. Webb detected water vapor almost immediately, strong and unmistakable. Then methane appeared, then carbon dioxide, and then came the detail that sent shockwaves through observatories everywhere. A chemical called dimethyl sulfide, which here on Earth comes almost exclusively from living organisms in our oceans. This wasn't a one-time reading either. It repeated consistently across multiple separate observations, which is exactly why scientists couldn't simply dismiss it as noise or instrument error. Now, to be completely fair, researchers are being extremely careful about this. Nobody is standing up and declaring that alien life has officially been found. Dimethyl sulfide could theoretically form through non-biological chemical pathways that haven't been identified yet. But here's what makes this discovery genuinely remarkable. Every single time, scientists have tried to explain this specific signal away using ordinary, non-living chemistry. The proposed explanations keep requiring increasingly exotic, increasingly unlikely combinations of conditions. Meanwhile, the simplest explanation left standing keeps pointing toward one thing, and one thing only: biology. When every alternative theory keeps getting more complicated while the simplest explanation stays exactly where it started. Scientists eventually have to start taking that simple explanation seriously, even while maintaining exactly the level of caution a discovery this significant deserves. Try to picture what this planet might actually look like. A world wrapped in a dense envelope of hydrogen, hiding an ocean underneath deep enough to comfortably swallow entire mountain ranges. Weak sunlight filtering through thick clouds, gently warming a stable twilight zone caught between permanent day and permanent night. If any planet discovered so far could genuinely host life, K2-18b may be our very first real contender. It's worth remembering just how quickly this planet's reputation changed. A few years ago, almost nobody outside the astronomy community had even heard of K2-18b. It was one entry among thousands of cataloged exoplanets, sitting quietly in a database, waiting for a telescope powerful enough to actually study it properly. Now it's arguably the single most talked about planet in the entire search for life beyond Earth, and that shift happened almost overnight, the moment Webb's data started coming in. It's a reminder that some of the most important discoveries in science aren't found through some dramatic new mission built specifically to look for them. Sometimes they're sitting quietly in plain sight for years, simply waiting for the right instrument to finally take a proper look. Number 2 brings us to a much sadder story, because this is the planet that should have been humanity's easiest win, and instead became one of Webb's most frustrating results. It's called Proxima B, and it orbits Proxima Centauri, the closest star to our own sun, sitting just over 4 light years from Earth. When it was first discovered, astronomers immediately started imagining oceans, atmospheres, and maybe even the faint outlines of continents somewhere beneath alien clouds. It represented everything scientists had hoped to eventually find close to home. But when Webb finally turned toward it, the excitement quickly collapsed into disappointment. Proxima B orbits so close to its host star that it essentially vanishes into the surrounding glare. Webb simply can't separate the planet's faint reflected light from the far more intense radiation constantly pouring off its parent star. We know the planet exists, we can measure its orbit and its gravitational pull with real precision. But we genuinely cannot see what's happening on its actual surface. And there's a deeper problem layered underneath that one. Proxima Centauri isn't a calm, well-behaved star. It's a red dwarf notorious for violent solar flares, sudden bursts of radiation intense enough to strip an entire planet's atmosphere away within what amounts to a geological instant. If Proxima B once had oceans or any kind of breathable sky at all, they may have already been blasted away long ago. Or the planet could be permanently locked, facing its star, with one entire side scorched under endless daylight while the other freezes in permanent darkness, leaving only a narrow strip caught between perpetual day and perpetual night, with any real chance at habitability. This is exactly what makes Proxima B so haunting to scientists. It's the nearest world to us, the planet humanity has openly dreamed about visiting one day, and yet it may remain permanently just out of reach of true understanding. At least until an entirely new generation of instruments gets built specifically to cut through that overwhelming stellar glare. Before we get to number 1, there's a story that deserves a spot on this list too, even though it isn't a triumph. It's actually one of Webb's most painful discoveries, and it involves a system that was once considered the crown jewel of the entire exoplanet field. It's called TRAPPIST-1, and for years it represented the closest thing scientists had found to a miniature version of our own solar system. 7 Earth-sized worlds orbiting a single star, several of them sitting comfortably inside the habitable zone. Entire conference sessions were built around this system. Magazine covers speculated about what kind of life might be quietly waiting on one of those 7 planets. Then Webb actually looked, and the results were devastating. The first 2 planets studied showed no atmosphere at all, not a thin, wispy layer, not even a faint trace clinging to the surface, just completely bare rock, constantly bombarded by radiation from their host star. Without any atmosphere at all, these planets can't retain heat, can't shield themselves from radiation, and can't sustain the basic chemistry required to support life in any meaningful way. A system once treated as a genuine galactic oasis instead turned out to be little more than a chain of sterile, lifeless worlds. Here's the twist, though. This disappointment ended up teaching scientists something incredibly valuable. It turns out that simply sitting inside a habitable zone isn't enough on its own. The type of star matters just as much, if not more. TRAPPIST-1's host star is what's known as an ultra-cool dwarf, and these stars tend to flare violently and unpredictably, especially early in their lives, stripping away atmospheres long before life would ever get a real chance to take hold. Because of this one discovery, researchers have started shifting their search strategy entirely, prioritizing calmer, more stable stars over simply chasing any rocky planet that happens to sit inside a technically defined habitable zone. Sometimes, the most important discoveries aren't the ones that confirm what we hope to find. They're the ones that quietly correct our entire approach going forward. Before we get to number 1, there's a discovery worth mentioning that didn't make the top of tonight's list, but genuinely deserves your attention. A scorching gas giant called WASP 39b. Scientists expected the usual predictable profile for a planet like this, sitting close to its star with a boiling, unremarkable atmosphere. Instead, Webb uncovered one of the most chemically complex atmospheres ever properly recorded on any planet. Water vapor, sodium, potassium, carbon monoxide, methane, and sulfur dioxide. A molecule that only forms through chemical reactions triggered by intense stellar radiation, something that had previously only existed in theoretical models. No telescope had ever actually witnessed this kind of active chemistry happening in real time on another world before, and it proved that even the most extreme, hostile-looking planets can still host genuinely complex, evolving atmospheres. And that brings us to number 1, the strangest, most unsettling discovery on this entire list. And it isn't even a single planet. It's a pattern that shows up across every single planet Webb has studied so far. Webb has now scanned dozens of worlds, oceans, atmospheres, storms, chemistry that closely resembles early Earth in multiple different ways, and yet, across every single one of those planets, there's still no confirmed sign of actual biological life anywhere. Not one undeniable signal, not one moment where scientists could say with total certainty that life exists beyond our own planet. Scientists have started calling this the Great Silence. Every single ingredient life supposedly requires keeps showing up scattered across the galaxy in genuinely staggering abundance. Water, organic molecules, stable temperature zones, rocky surfaces sitting comfortably in habitable orbits. And yet, the actual spark of biology itself remains stubbornly missing from every world we've managed to study closely enough. It raises a question researchers are only now beginning to take seriously. Maybe the jump from simple chemistry to genuine self-sustaining life is a far rarer, far more improbable event than anyone previously assumed, even when every other necessary condition appears to line up perfectly in a planet's favor. Or maybe the silence we're hearing says considerably more about the limits of our current technology than it says about whether life actually exists out there. Our instruments, however impressive they already are, might simply not be sensitive enough yet to catch the specific, faint biological signals we'd actually need to detect real life from this kind of distance. Think about what that really means for a moment. We're not looking at empty space out there. We're looking at a galaxy absolutely packed with planets that seem to have almost everything required for life, and still somehow coming up silent every single time we look closely enough. That contrast is genuinely unsettling to sit with, and it's exactly why scientists keep pointing Webb toward new targets every single month, hoping the next planet on the list finally breaks that silence for good. Before we wrap up, it's worth taking a moment to appreciate exactly how Webb is pulling any of this off in the first place, because the engineering behind it is honestly just as wild as the discoveries themselves. Webb doesn't orbit Earth the way older telescopes did. It sits nearly 1 million miles away at a gravitationally stable point in space, staring outward with a mirror over 6 meters wide, assembled from 18 individual gold-coated segments that had to unfold perfectly once it reached space, with essentially zero room for error. If even a single one of those segments had failed to deploy correctly, none of tonight's discoveries would exist. Every planet on this list only exists in our knowledge because that entire unfolding sequence worked exactly as engineers hoped. And once Webb is collecting light, it isn't simply snapping a photograph. It's breaking that light apart into a spectrum, essentially reading a chemical barcode, and identifying which specific wavelengths are missing because they were absorbed by particular molecules inside a planet's atmosphere on the way toward us. That's the actual process behind everything we've talked about tonight. It's how scientists know there's water vapor sitting on one planet, or dimethyl sulfide hiding in the atmosphere of another, without ever physically visiting either one. It's real chemistry, conducted from a distance of trillions of kilometers, using nothing but light, that had already been traveling toward us for years before Webb's mirror ever caught it. There's something genuinely humbling in that idea if you sit with it for a second. Every planet we've counted down tonight, the orphan giant drifting alone in the dark, the possible ocean world hiding a chemical signature of life, our nearest neighbor permanently blinded by its own star, the furnace, a hot world running active chemistry nobody expected, and the sterile, silent system that once seemed so promising. None of them were even remotely detectable to human beings until just a few decades ago. For nearly the entire span of human history, every person who ever lived looked up at the night sky and saw nothing but scattered points of light, with absolutely no way of knowing which ones, if any, had planets circling them at all. We are the first generation of humans who actually get to ask these questions using real data instead of pure imagination and guesswork. And Webb is nowhere near finished. Mission planners expect it to keep operating for years to come, which means more targets, more atmospheres, more chemical fingerprints pulled directly out of ancient starlight. Somewhere in Webb's future observation schedule might already be the exact planet that finally breaks the Great Silence for good. Nobody knows which one it will be yet, or when that moment will actually happen. That uncertainty is exactly what makes this such an extraordinary story to keep following. So there you have it. 5 discoveries that are quietly rewriting everything we thought we understood about planets beyond our own solar system. A planet that shouldn't exist, according to our own formation models. A world that might be hiding an alien ocean beneath its clouds. Our nearest neighbor, permanently hidden behind its own star's blinding glare. Chemistry happening in real time on a planet hotter than a furnace. And a silence stretching across an entire galaxy that scientists still can't fully explain. This is genuinely only the beginning of what Webb is going to find. Every new target it studies could be the one that finally answers the question humanity has been asking since we first looked up at the night sky. Think about which one of tonight's discoveries surprised you the most. Was it the orphan giant that shouldn't exist where it's sitting? The possible ocean world with a chemical signature scientists still can't fully explain away? Or the quiet, unsettling silence stretching across an entire galaxy full of promising planets? Drop your answer in the comments below, because we genuinely want to know which of these mysteries you'd want us to dig even deeper into next. If you want to know the exact moment the next discovery happens, make sure you're subscribed to this channel with notifications turned on right now, because the next planet on this list might be the one that changes absolutely everything we thought we knew about our place in this universe.